The key difference between a stack and a queue. Whereas stacks are last in, first out, LIFO, queues are first in, first out, FIFO. Think of a line at the bank or the supermarket. We can add multiple people to the queue, but when we want to take something from the queue, they should always be taken from the front of the queue. One gets taken from the front, the others shuffle up to the front of the queue, and the process continues. Now, queues are used a lot in programming. Think of sending jobs to a printer. As the printer can only deal with one thing at a time, it has a built-in queue. You queue up multiple jobs for printing, and it will take those jobs in the order that they were submitted. First in will be first out. And queues are very commonly used in multi-threading and concurrency situations to keep track of what tasks are waiting to be performed and making sure we take them in that order. Now, just as with the stack, the idea of a queue as an abstract data type is that we do not care about the actual implementation of this data structure behind the scenes. Whether this is implemented as a linked list or a dynamic array or anything else, we shouldn't have to worry. All we want to be able to do is add an item to the end of the queue and remove an item from the front of the queue. And as with stacks, we should not even be thinking about numeric indexes. If you're asking the question, but how can I pull an item from the middle of the queue, you should be looking at a different data structure. Now, whereas the terminology for working with stacks has centralized on push, pop, and peek, the terminology for working with queues is a little more scattered. As with arrays, we'll actually find several different words used for the idea of adding to a queue and removing from a queue. However, the key behavior is absolutely the same. All queues are a first in, first out data structure. As a handful of examples, we have the queue class in C#. This is one of the simple available ones here. The two methods there that are most useful are the enqueue to add an object to the end of the queue and to dequeue to remove and return the object at the beginning. Java is a little more involved. Queue is an interface just as list was, so we can't create a queue object. Instead, there are multiple concrete classes that do support queue behavior, including array blocking queue and concurrent linked queue. Java has several specialized queue classes, and these are mainly for different multi-threading and concurrency situations. For simple queue behavior, the linked list class that we've already seen actually supports queue behavior. It can act like a queue. In Java, we use the words add and remove when working with queues. Over to Python, it does have a queue class, and the queue class uses put and get for the idea of adding and removing from the queue. Having said that, the Python class is kind of targeted towards working with threading, which is very common with queues. You can certainly use it for other needs, but you'll see a lot of terminology talking about thread synchronization. And that's the same with Ruby. Ruby does have a queue class, but it's really just intended for synchronizing communication across threads. If you want standard queue behavior that's not targeted at multi-threading, you can just use the standard array class and the methods push to add to the end of the array, which we've already seen. But instead of using pop in Ruby, which would remove an item from the end of the array, just like a stack, we could use the method shift, and shift would return and remove the first element from the array, effectively from the start of the queue, and it would shift all the others down by one. Now, in Objective-C, there also isn't a built-in queue data structure, though you could certainly use the NS mutable array for this, just adding only to the end and removing only from the front. And in C++, there is a queue container in the standard template library where we use the methods push back and pop front. And this gets us started, but we're not quite done with stacks and queues just yet. We have a couple of specialized options to cover.